Okay, this is my Unit 6 multiple choice test corrections. And on this test, I got 5 out of 8. So the first question I got wrong was number 6. So the question asks, an object is in simple harmonic motion. Of the following quantities related to the object, which set of 3 can have the maximum magnitudes at the same instant of time? So the answer is displacement, displacement, acceleration, and potential energy. And the reason this is because displacement, max displacement is at the amplitude. So it can have max displacement there. Acceleration, since it's changing direction at the max amplitude, in simple harmonic motion, it'll have also max acceleration because it's changing direction. And the highest potential energy, yeah, because it's going to be either stretched the furthest if it's a spring, or it's going to be at the furthest point if it's on a pendulum, and it's going to have the most amount of potential energy to move back to the equilibrium position. So it'll have the highest potential energy because when it is furthest from equilibrium. For this one, I accidentally put kinetic energy on this one because I thought that, I don't know, I wasn't really thinking too well during this question. It doesn't make sense that it would have the highest kinetic energy during this question because as it's approaching, it's kind of like amplitude or endpoints. It's basically coming to a stop and changing direction, so it's going to have the least amount of kinetic energy at this point. Okay, next question was number 3. A block on a level surface is attached to one end of a spring, as shown in the figure above. The other end of the spring is attached to a wall. There is friction between the block and the surface. A person displaces the block from its equilibrium position and releases it. Which of the following shows the mechanical energy E as a function of time for the system? That includes only the block and the system. That includes the block and spring. So for this one, I didn't realize that the block, they treat it separately from the spring, so it doesn't have potential energy. It only has kinetic energy. And so that's why it'll kind of be like a wave, and it'll kind of go like this for the E block, the system with just the block in it. And for the block with this spring and the block, system with the block and the spring, it's just going to go straight down. And that is because the block and spring have both potential and kinetic energy, so there's not going to be these huge variances in energy. Since it accounts for both, the energy is going to remain constant, but because there's friction, it's going to slowly decrease. And yeah, both of these are decreasing because there's friction. Okay, and I also got number 1 wrong. 4 springs A, B, C, and D with the same unstressed length are attached to the ceiling, and a block is attached to each spring. The mass of each block and the resulting change in length of the spring as each block changes in equilibrium are shown in the table. Each block is then pulled down a small distance y and released. Which block will oscillate with the highest frequency? So for this one, you have to think of the equation F equals 1 over 2 pi root k over m from the period equation, but you just find the inverse of that since t equals 1 over f. So just inverse, you're able to just find the inverse of that equation from that original one. So as mass increases, the frequency will decrease, and as the k will increase, the frequency also increases. So you're gonna have to kind of just choose random springs in here and see how big is the mass, and if it's that much bigger, will the frequency also decrease too much? And you're gonna have to find the k from the equation. K equals mg over delta x. So for D, it's going to be 0.12 times 10 over total x 3. So pretty much 1.2 divided by 3 on this question. So you're going to have Z change in length is 0.03 since it's in centimeters. So, and you're going to get 40 for this one. And then you're just going to have to solve for the other equations and see which values you get for that. And here's the work.